back to another video for improper fractions. Sorry, improper integrals. This is still the type 1 improper integrals, but we're looking at comparing two different improper integrals that are kind of related and see how we can do that. So imagine that we have two equations, fx and gx. Fx is always going to be larger than gx throughout the domain which we're working on, which is a to infinity. And this only works if one function is always going to be larger or smaller than the other function throughout the domain. So if we imagine that, let's say that let's say that fx was convergent, right? Fx somehow, like later on, the nature of it comes down to 0 and the area of the graph doesn't grow infinitely. Well, that also means that gx by being always smaller than fx is going to have to also be convergent, maybe equally convergent or even smaller. It doesn't matter. Gx will always be smaller than fx, and therefore if fx is convergent, gx is convergent. The other way also works. If gx is divergent, it goes to infinity. Fx, by virtue of it being larger than gx, has to also go by infinity. So that's the kind of idea. So, and this only works if the range throughout we're working on, they are constant in terms of which one's larger than which. If that works out, then we can use that kind of reasoning. So I actually made another video here trying to do this, but I messed it up just a little bit. And so we're going to be redoing this, okay? So imagine that we had a question that says, show that the integral from 1 to infinity of x over x plus 9 plus 1 cube root is convergent. Now we're going to have to find a function that's larger than this. So we should be able to end up with a statement that says like x over x plus 9 plus x to the power of 9 plus 1 to the power of 1/3 is smaller than something, and this something, if we can prove that this something is convergent, then we can prove that this is convergent, right? And with these types of questions, they're going to be biased towards this kind of proof where we can show that it's, let's say, smaller than 1 over x to the n, and any n that is larger than 1, that equation is convergent. So, and we did that proof in the previous video. So how are we going to do this? Well, if we think, I know the answer, so it's a bit biased, but we're going to go through this. Okay, so let's say that we want to be able to compare somehow where it's just kind of like through spotting it. So we just got to try. But let's say we know for sure, and let's try cubing this first, right? We have x to the 9 plus 1 to the power of 1/3. So if we cube the whole function, what's going to happen? Well, it's going to be x cubed, and this one's going to be normal, right? And I'm going to show you how I went through it last time, but it led to dead end. So let's say we know that x cubed is going to be smaller than x to the 9 plus 1, granted that x is always larger than or equal to 1, right? Because if x was, let's say if x was larger than 0, x could be 0.5, right? And 0.5 to the 9 is actually smaller than 0.5 to the power of 3. But in this case, x is larger than or equal to 1. And so we can say that this here, actually, the smallest case scenario is, for example, when x is 1, and when x is actually 1, and we can see that on the left side 1 cubed is 1, and smaller than 1 to the 9, which is 1 plus 1 is 2. So the smallest case scenario, this is like this. And I was thinking we could do something like this where we divide by x to the 9 plus 1. So this would be x cubed over x to the 9 plus 1. Yep, the whole thing, and this would be smaller than or equal to 1. Keep in mind that the signs of the crocodile sign doesn't change because we know that x is larger than 1, and therefore this is a negative number. And I was thinking we could somehow compare this. We could compare x cubed over x to the 9 plus 1. We can compare it somehow to the original one, which we had was x over x to the 9 plus 1 to the power of 1/3, right? But we found that actually this, if you see, wait, let me see. Oh, and I was thinking we could cube root it to get it similar. So this would be x, sorry, ignore this. Let's cube root everything. So this would be x cubed, sorry, ignore me what I said. I was thinking that I could say that, oh, let's divide both sides by x to the 2, right? So that would be x over x to the 9 plus 1 is smaller than 1 over x squared. So if x squared, we know that's convergent because n is larger than 1. But this let's compare this to this one, right? Compare it to our original function, which is x here, and we can see that the denominator here is smaller. If it's smaller, right, because it's cubed, the same denominator, but one is cubed. So this denominator is smaller, and if you're dividing by a smaller number, the total one is bigger. So we know for sure that this one's going to be bigger. Well, if this one's bigger than that one, then we can't say that this one is smaller than this because it just isn't. So we can't be sure whether this is smaller than 1 over x squared or not. So this is kind of a scrapped idea, but there's another way where we can do this. Let's say that we start off with x to the 9, and then let's compare it with the denominator, right? So how close can we get this? X to the 9 is definitely smaller than x to the 9 plus 1, simply because x is larger than or equal to 1, and therefore the small scenario is 1 to the 9, which is 1, and smaller than 1 to the 9 plus 1, which is 2. Okay, and then let's try doing that division. So x to the 9 over x to the 9 plus 1 smaller than 1. Okay, and remember the sign of that doesn't change because it's a positive number. And then we get, let's cube everything, right? Cube root everything. So x to the 9 cube root would simply be, actually x to the 9 can't be cube root. Oh, but what we can do to x to the 9 is we can, let's see, so we can take x to the 9, and let's say that we take x to the 9 and we divide both sides. Sorry. You know what? Yeah, let's keep it first. Let's keep it first because we got to somehow end up with something over here, right? Yeah. So let's try, let's try to cube root everything first. So the cube root of x to the 9, so we're basically cube rooting both sides. I have 1/3. Okay, so that's looking a bit tough. Let's do this. So the top function would be x to the 9 cubed, 9 cubed, that would just be 9 over 3 over x to the 9 plus 1, also 1 over 3. Okay, the power of 1. Cube root of 1 is 1, right? And now we gotta kind of somehow bring some stuff down. We can compare, let's try comparing both sides really quick. X over x to the 9 plus 1 to the power of 1/3. Compare that to x to the 9 to the 3 over x to the 9 plus 1 to the power of 1/3. So we can see that same denominator, but this one has a larger power, right? As long as this power isn't equal to 1, it's going to be bigger. So we can kind of maximize it in a way where we want this to be as small as possible so that we can give the most x to this one where it can be as big as possible. So that the bigger it is, the more likely that it's going to be convergent, right? So let's see what we could do. 9 over 3. Let's see if we could give 9 over 3 is actually just x to the 3. Yeah, 9 to 3 is actually just x to the 3. Why did I? Yeah. Okay. X to the 9, cube root x to the 3. Actually, this makes it really simple. Then this would just be, let's try dividing by x squared. So this gives us the equivalent thing. So let's rewrite this. And then let's give x squared to here, 1 over x squared. So ignore this for a second. 1 over x squared, and this is still mathematically true. And this is the same function as this left one here, which is in the equation. So we know for sure that 1 over x squared is going to be larger than the function that we have here. So if now we can prove that from 1 to infinity, 1 over x squared dx, if we can prove that this is convergent, then we can prove that the other one's convergent since it's larger. And we know because the theorem tells us that since x 1 over x n and n is larger than 1, therefore the integral from 1 to infinity of 1 over x squared is convergent. And because we can prove it up here, right? Because x to the 9, x over x to the 9 plus 1 all cube root is smaller than 1 over x squared. Therefore, if 1 over x squared is convergent, therefore, integral from 1 to infinity of the original equation x over x to the 9 plus 1 cube root is also convergent. Oh gosh, I can't write it. So yeah, that's the way you do that. That was a lot of trick. I think the most difficult part is being able to kind of equate the proof here. And that was definitely something I was struggling with. So that just takes practice, but hopefully you guys can see the method behind the madness. So yeah, thank you guys so much.